Welcome back to Where on Earth. Two places can sit on the same latitude and have completely different climates. Labrador in eastern Canada lies frozen for much of the year. London, on the same latitude, stays green and relatively mild. Scotland is warmer than parts of Canada far to the south. Norway supports cities and farms, where Siberia at similar latitudes faces severe Arctic cold. Why? Because Western Europe is warmed by an invisible river flowing through the Atlantic Ocean, not a river of fresh water, but a vast current of warm salt water moving north from the tropics. Scientists call the wider system the Atlantic Meridional Overturning Circulation, or AMOC. Many people know one surface branch as the Gulf Stream, but the AMOC is much larger than a surface current. It is a three-dimensional conveyor belt spanning the depth of the ocean. Warm tropical water flows northward near the surface. As it reaches higher latitudes, it releases heat into the atmosphere. Westerly winds then carry that warmth across Britain, France, Germany, and Scandinavia. This is one reason Europe is much warmer than latitude alone would suggest. Then the cooled water, now colder and saltier, becomes denser and sinks in the North Atlantic. Deep currents carry that water southward beneath the surface, completing the circulation. It is one of the largest physical systems on Earth, but this invisible river is weakening. As Greenland melts, increasing amounts of fresh water enter the North Atlantic. Fresh water is less salty and less dense, making it harder for surface water to sink. If sinking slows, the whole conveyor slows. Recent studies suggest many climate models may have underestimated that decline. Observations indicate the AMOC has weakened significantly since the 20th century. Scientists continue to study how fast it may weaken further and whether tipping points exist. Why does this matter? Because the effects would be global. Europe could cool regionally even as the planet warms overall. Sea level rise could accelerate along parts of the eastern United States. Rainfall belts and monsoon systems in Africa, South Asia, and South America could shift. That means impacts on food, water, and ecosystems. Far beyond the Atlantic, there is historical precedent. Near the end of the last ice age, large pulses of meltwater likely disrupted North Atlantic circulation and triggered abrupt climate changes, such as the Younger Dryas. Ocean circulation has changed before. The lesson is bigger than Europe. Climate is not separate systems acting alone. The Arctic, oceans, rainforests, monsoons, and coastlines are connected. Change one major part and the others respond. The AMOC has helped shape the geography of civilizations for thousands of years. Now scientists are watching whether that invisible river is slowing into a new era. Subscribe to Where on Earth for weekly geography that reveals the forces shaping our world. Because the world looks very different when you understand the invisible river beneath the ocean's surface.